in a log-log regression where natural logs are used on both sides of the equation, the key assumption is that a 1% change in some x variable is associated with a constant percent change in the dependent variable y, again, regardless of the actual value of that x variable. So consider the sample regression function relating median housing price in a certain area to the amount of nitrous oxide in the air in parts per million and the average number of rooms for houses in that certain area. And we're taking the natural log of both the dependent variable price as well as the independent or explanatory variable of amount of nitrous oxide in the air. And we've actually already seen how to interpret this coefficient of 0.306 on rooms. We interpret that as we would a log level regression coefficient. So the dependent variable of price is in log, but the independent variable of rooms is not, and therefore we multiply the 0.306 by 100 to get our interpretation, which is a 1 unit increase in the average number of rooms is associated with a 30.6% increase in median housing price, holding other regressors constant. Note that this interpretation is just a rough approximation because the coefficient of 0.306 is actually a relatively large number, and this interpretation is only precise for small values of this coefficient. To interpret the coefficient of negative 0.718 on nitrous oxide, since both the dependent and independent variables in this case are in logs, we'd say that a 1% increase in the level of nitrous oxide is associated with a 0.718% decrease, because we have a negative coefficient, in median housing price holding other regressors constant.